So now that we've talked about what power functions are, let's talk about how we can adjust them graphically. We can transform them. So problem number one here, we've got, sorry about that, the linear function, we have the quadratic function, and we have the cubic function. All right, so it's the first three of the power functions, degree 1, degree 2, degree 3. And part A says, what happens when the A value is negative? Now you might look at this and say, what A value? So remember, when we're doing these power functions, all of them are written in the form P of x is equal to ax to the n, where n is that degree. So when it talks about the A value, we're talking about what happens when this number in front of the power function is negative. And so if you think about it, when we had the quadratics, those are the ones we've been working with the most in these first few units. When we talked about an A value that was negative, we were concave down. And that's actually what's going to happen with all of these functions. Now, not that they're going to become concave down, but what happens, right, when this A value is negative, this is a reflection over the x-axis. All right. So in terms of writing the function, all right, our first function here is and I'm going to go, match them up top to bottom here. So the first function here is our linear function. It's just x. So if our A value is negative, we would have negative x. Graphically, do you notice how this graph is going from left to right? It's increasing. Well, now what we want to do is reflect it over the x-axis. So this piece that's down here in the lower left is going to move to the upper left, and this piece in the upper right here is going to move to the lower right. So what that would look like is something like that. Okay, my line's not perfectly straight, but you get the idea. That's the linear function. Okay, so then if we move on to the quadratic, okay, again, we're going to make our A value negative, so negative x squared. And that's going to cause this concave up parabola to flip down, and it would become concave. Oops, hold on a second. Let me actually hit the origin here. It would become concave down. So again, it basically took that graph that was facing up and just pushed it down over the x-axis. It reflected it over the x-axis. And our last function here is the function, this is our cubic function. So this would be negative x cubed, okay? And so again, we're going to take this lower left section, reflect it up to the upper left. The upper right here is going to reflect to the lower right, okay? So that S-shaped curve, instead of starting in the lower left, is going to start in the upper left and end in the lower right. Okay, but we still going to keep the curve part of it. So still that kind of little S shape there. Okay, so that's what happens when the A value is negative. All right, that's one of our transformations that we can talk about. It's a reflection over the x-axis. All right, what happens when the B value is negative? Now, that doesn't look kind of like what we've talked about, but what ends up happening here is there is a value that's attached to x inside the basically parentheses, if you were to write them, and it would look something like this. So our power function here is equal to A times bx, and then actually, hold on, let me make that an n, so it applies to all of these, okay? So when the B value is negative, okay, so that is directly attached to the x value. That is actually a reflection over the y-axis, okay? So instead of reflecting top to bottom, we're going to reflect left to right, okay? So in a line, it's basically going to look like any other reflection. So the original line, and I'm actually going to draw it in, I'll draw it in red highlighter. So our original line looked like this, and I'll delete that in a little bit just so you don't get confused by it. So now instead of this lower left, right, this line in the lower left, we're actually going to push this line in the lower left to the lower right. And this piece in the upper right is going to be pushed over to the upper left. All right, so that would look like that. Okay, and I'm going to go ahead and delete out that highlighter part that I put in there just so you don't think it's part of the actual graph. That, remember, was just the original function. All right, in the quadratic function, okay, so that would look, when we write the equation, it would be negative x in parentheses squared. Okay, so that reflection over the x-axis, I'm going to do the same thing. I'll draw a little quadratic graph here. Not great, but we'll make it work for us. So this piece over here in the upper left is going to reflect to the upper right. The upper right is going to reflect to the upper left. So it's moving left to right here. The thing is, your quadratic graphs and really all of your even degree power functions, they're symmetrical to the y-axis as it is. So this reflection won't do anything, okay? It's still going to look identical to what the curve used to look like, because this piece in the upper left is the same as the piece right here in the upper right. Okay, it is literally symmetrical. So it's not going to look any different when you do that reflection over the y-axis for the even degree power functions. Okay, so let's see what happens when we have an odd degree power function. In this case, we're going to talk about the cubic function. So we would have negative x cubed. So the original cubic function is that S-shaped curve, lower left to upper right. Okay, but now because of the reflection, we're going to take this lower left section, reflect it over the y-axis, so it would come into the lower right. And then this piece in the upper right is going to reflect over the y-axis to the upper left. So it would look something like that. Okay, again, I'm going to delete out the original curve, okay, and so you can now see, and I'm going to zoom out as best I can here. So when we have these original functions, all right, this was the original power function up at the top, then you've got the reflections over the x-axis, and then these are what happens when you take these original functions and reflect them over the y-axis. All right, so again, I'm going to go ahead and cut the video here on this one, and in the next video, I'm going to start talking about end behavior and what that looks like and how we write it. Let me know if you have any